This is a presentation about the house sale prices project that we were given by our school EDSA, derived from a Kaggle challenge, which aimed for us data scientists to produce a model using advanced regression techniques to predict house sale prices for a certain neighborhood in the United States of America. So my name is Thato Mokoka, and I'm an aspiring data scientist from EDSA, and this is the start of the project. Now, when we received the project, we had to produce a roadmap, and then the roadmap actually is divided into a problem statement, the hypothesis, exploratory data analysis, model methodology, model selection, and finally the conclusion. Now, the problem statement has already been said in my first sentence, which is we were expected to produce a model to produce house sale prices using advanced regression models, and then we're doing this by basically taking the data, analyzing it, cleaning it, feeding it into a model, basically training the model in order to produce a prediction with new given data. And what are the outcomes of this whole thing? And the outcomes, simple, the prediction. Now, with science and mathematics, every model follows a life cycle. And then in our case, for example, the facts will be our independent variables, which in this case we were given 79 variables and one independent variable, which is our sale house prices. And then out of all of this, we'll produce a hypothesis, and then the hypothesis, once tested, will come a theory. And then from all of that, the end game of this whole process is the prediction. Now, the hypothesis was that we are going to use the independent variables to train our model so that we get our sale price, which is the dependent variable. Now, our data was divided into two sections, which is numerical and categorical, and we basically defined a program which will differentiate between the two so that we know what to do in order to further analyze the data and decide on what to do, especially in terms of imputing and cleaning the data. Now, we're going to start with one of the most important variables, which is the sale price variable, which we had to check the distribution. Well, on the left, before transformation, you can see that the sale price is positively skewed, and also on the GG plot, the data points are moving away from the lineage. Now, after transformation, you can see that the points are then distributed on the line on the GG plot, and on the histogram you can see that the data is normalized. Then this helps us into basically informing our model to predict better. And it's just a theory about the skewness and the kurtosis. Now, we found missing data on our data set, and then we had to clean it, and that includes imputation, because with categorical variable, for example, we had to either choose mode, for an example, which just gives a frequently used point in a variable and just use it to fill in a variable, or use min on numerical variables, or median, such things, and so on and so forth. And then with feature engineering, we had to just change some of the variables so that we make them smaller and fit them better in the model. And then we encoded our data so that the model can understand it. And then we did feature selection to either remove or add more features, and then basically use the Kaggle for us to be informed which model performs better. Now we used different functions such as Lasso, regression, Bayesian rich, elastic net, and then further decided that we're going to use the average of all the models that we mentioned, and then that will further give us a better score. And then the end score was 0.12. Thank you very much.